Welcome to the deep dive. Today, we're digging into something really foundational in the blockchain world, a set of technologies, really, that promises to connect, well, pretty much every corner of our digital world.
Yeah, it's fundamental stuff.
We're going to try and unpack the core architecture of how modern blockchain applications get built, and maybe even more importantly, how they finally manage to talk to each other.
That's right. And our mission here today, is to try and simplify these components because they can seem pretty complex at first glance. We'll be looking at the Cosmos SDK, the consensus engine underneath it all, Tendermint, though it's called Comet BFT now, and the really revolutionary Inter-Blockchain Communication Protocol, IBC.
IBC, yeah.
The idea is you'll leave this session with hopefully a clearer grasp of how these pieces fit together, not just building individual chains, but enabling this whole new era of interoperability, what people call the Internet of Blockchains.
Okay, so to really get that big picture, that Internet of blockchains, we kind of need to start at the bottom, right? At the foundation. Because if you look back at those early blockchains, they ran into some pretty big hurdles. Performance limits, huge energy use, sometimes governance was just clunky.
Definitely.
And for proof-of-stake systems specifically, there was this really tricky problem called nothing at stake.
Ah, yes, nothing at stake. That was a major headache for early proof of stake.
Yeah.
Basically, validators could, theoretically, try to validate multiple different versions of the chain at the same time.
With no real penalty.
Exactly. No real cost for misbehaving,
Okay.
which, creates uncertainty, potential security holes. And what's really interesting is how Tendermint, which Jae Kwon came up with back in 2014, tackled these core issues directly. It wasn't just another blockchain attempt.
Right.
It was designed as a kind of ready-made solution for the networking and the consensus parts.
So like a pre-built engine, developers could just plug their own ideas into it without reinventing the wheel every time?
Precisely.
Yeah.
You can almost think of it as the operating system for a blockchain. The real genius here, I think, was modularizing blockchain development.
Modularizing.
Okay.
Yeah, it shifted things from build everything from the ground up to here's a super solid foundation for consensus and networking. Now go build your specific application on top. That didn't just make things easier. It really unlocked a wave of innovation for application-specific chains.
Gotcha.
And just to be clear, Tendermint is now called Comet BFT. But it handles those critical networking and consensus layers. It can support state machines written in, well, pretty much any programming language.
Any language. Wow.
Yeah, and Comet BFT is built tough. It keeps running, even if, say, up to a third of the machines validating it fail or act maliciously. It's known for being high performance, consistent, flexible, secure. And it has this thing called strict fork accountability.
Strict fork accountability. What does that mean, practically?
It means if validators do try to cheat, if they try to create conflicting blocks, basically trying that nothing at stake trick, they can be cryptographically identified and penalized.
Okay, so it directly solves that problem. Directly solves it. And transactions. Once they're in a block, they are finalized, irreversibly. That gives you a level of certainty that some other systems, like probabilistic ones, often struggle to match.
That certainty, that finality sounds incredibly important. So, okay, Comet BFT is this powerful engine for consensus. How does it actually talk to the specific application a developer is building, like the game or the DeFi protocol or whatever?
That's a great question, and it leads us to the application blockchain interface, or ABCI. It's a really crucial piece of abstraction.
Abstraction.
Yeah, think of it like this. Comet BFT is running in one process, doing its job, networking, consensus, all that. And the application logic, that's running totally separately in another process.
Okay.
ABCI is like a socket protocol. It's the messenger between these two processes. And because it's just a protocol, it doesn't care what language the application is written in.
So that's how it supports any language.
Exactly. And the really profound thing about ABCI is how it completely separates consensus from the application logic. Developers don't have to worry about the low-level blockchain stuff anymore. They can just focus on building their cool application features in whatever language they like, knowing Comet BFT will handle the consensus and talk to it via ABCI. It really enables specialization.
It's like separating the engine from the car's dashboard and controls. Specialists can work on each part.
What's a good analogy?
So how does that ABCI communication work? Like, what messages are they actually sending back and forth?
Well, ABCI defines a few key methods or calls. You have CheckTx, for instance. Think of that as Comet BFT doing a quick check, asking the application, hey, does this transaction look basically okay? Is it formed right? Is it obvious spam? before it even gets considered seriously.
A quick sanity check.
Right. Then, when Comet BFT is actually building a block, it uses DeliverTx. That tells the application, okay, execute this transaction now, update your state.
And that state update has to be the same everywhere, right?
Absolutely. Deterministic. Then there are messages like BeginBlock and EndBlock. These get sent even if a block is empty, which lets the application do things on a regular schedule, or maybe aggregate data at the block level.
Okay.
And finally, there's commit. That's when the application basically saves its current state to its database. And crucially, it calculates a unique fingerprint of that state, a Merkle root hash. That hash has to be deterministic. Every single node running the chain must calculate the exact same hash for the same state. That's fundamental for consensus.
It's really cool how these pieces click together, and tying it all together, this link between the engine and the app. You mentioned the blockchain is essentially a replicated state machine. Can you unpack that a bit?
Yeah, absolutely. At its core, a blockchain really operates like a replicated state machine. That's a concept from computer science. A system has a state like the current balances of all accounts or the position of pieces on a chessboard. And a transaction acts like a state transition function. Given the current state, in a valid transaction, the machine moves deterministically to a new state.
Deterministically meaning always the same result for the same input.
Exactly. No ambiguity. Every node processes the same transactions in the same order and must arrive at the exact same final state. That determinism is what ensures everyone agrees on the history and the current situation. It's what makes the ledger immutable and trustworthy.
Okay, that makes sense. So we've got this powerful Comet BFT engine. We've got ABCI letting it talk to any application. How do developers actually build these different applications, these state machines? What tools help them put it all together without starting from absolute zero every time?
Right, because building everything via just ABCI calls would still be a lot of work. And that's exactly where the Cosmos SDK comes in. It's a massive accelerator for developers.
What's the SDK?
Think of it as a toolbox or maybe like a framework. It gives developers a huge head start. It provides a set of pre-built, well-tested modules for all the common things you need in the blockchain.
Like what kind of things?
Oh, stuff like handling user accounts and keys, managing tokens, setting up governance rules and voting, staking logic, and even, crucially, modules for talking to other blockchains using IBC.
Ah, okay, so reusable parts.
Exactly, reusable parts. Instead of coding, say, how tokens are transferred from scratch, you just grab the SDK's bank module, configure it a bit, and plug it in. It's like building with really high-quality Lego bricks instead of trying to carve every single piece out of wood yourself. Saves a ton of time and effort.
That modularity does sound incredibly efficient. Can you give maybe a concrete example? How would that checkers game idea work with the SDK?
Yeah, the checkers example is great for this. So using the Cosmos SDK, a developer wouldn't just be dealing with raw ABCI calls. They'd define things within the SDK structure, like how a query function fetches the current board state for a user, how the initchain function sets up a new game when the chain first starts, how CheckTx, maybe using an SDK message type, verifies that a move transaction looks right, like it has the 4 numbers for the start and end squares.
Right, the basic format.
Then, DeliverTx, likely implemented as a message handler in the SDK, would apply the actual game logic, move the piece, check for captures, check for wins, and emit events like piece moved or player won. And commit would use the SDK's data storage mechanism, often called a keeper, to save the new board state persistently.
And the SDK helps with more complex things too, like knowing who's who.
Absolutely. Things like identifying players using accounts and digital signatures. The SDK has modules for that, often bank. Supporting multiple games happening at once, the SDK state management and keeper patterns handle that data separation. It streamlines all that complexity.
That makes it much clearer how you'd actually build something practical. Okay, this naturally leads us to the really big vision, right? Connecting all these different specialized blockchains built with the SDK, the Internet of Blockchains, and this protocol, IBC.
Exactly. If we zoom out now, the whole point of the Cosmos network, the big picture, is tackling that fundamental challenge, interoperability. For so long, blockchains were like these isolated islands, these walled gardens.
Yeah, couldn't talk to each other easily.
Right. Couldn't easily send value or data between them. The Cosmos vision, which Jae Kwon and Ethan Bookman laid out in their 2016 white paper, was pretty radical at the time. They proposed a network of many independent blockchains. They call them zones.
Zones, okay.
And these zones wouldn't necessarily connect directly to each other. Instead, they'd connect through central hubs. The Cosmos hub was the very first one.
So the hub is like a central router or switchboard for these zones. Why not just connect every chain directly?
Scalability, mainly. Imagine if every chain had to maintain a direct connection to every other chain. The number of connections just explodes. It's quadratic growth. If you have, say, 100 zones, you'd need nearly 5,000 direct connections.
Whoa, yeah, that sounds completely unmanageable.
Totally. So with the hub and zone model, each zone only needs to connect to a hub. Much simpler. And the hub then plays this critical role in tracking tokens across zones, making sure tokens aren't accidentally duplicated or double spent as they move around. It also helps isolate failures. If one zone has problems, it doesn't take down the whole network.
That makes a lot of sense for building a large, resilient network. Okay, so IDC, the Interblockchain Communication Protocol, is that the actual language these zones and hubs use to talk to each other, like the TCP/IP for blockchains?
That's a fantastic analogy, yes.
Yeah.
IBC is designed to be that standardized, permissionless, and importantly, trust-minimized protocol for blockchains to communicate.
Trust minimize. What does that mean compared to other ways chains connect?
It means you don't have to rely heavily on trusting a third party or a specific group of validators on some intermediary bridge chain. IBC breaks down those silos, letting different kinds of blockchains, even ones with totally different consensus or governance, reliably send data packets back and forth.
Sure.
It's fundamentally about secure data relay, authentication, making sure messages arrive in the right order.
Okay, but how does it achieve that without trust? If I send tokens from chain A to chain B, who actually moves them? Don't I have to trust someone?
That's where the relayers come in, and how IBC uses light clients. It's pretty clever. Relayers are just off-chain processes. Anyone can run one. They're permissionless. They watch chain A for outgoing packets, let's say your token transfer request.
Okay.
When a packet is committed on chain A, the relayer picks it up, along with a cryptographic proof that this packet commitment really happened on chain A. It then submits this packet and the proof to chain B.
And chain B just believes the relayer.
No, that's the key. Chain B runs a light client of chain A. Think of it as a small, efficient way for chain B to keep track of chain A's block headers and validator set changes, all verified cryptographically. So chain B uses its light client to check the proof submitted by the relayer. It verifies for itself that the packet commitment is valid according to chain A's consensus rules.
Ah. So chain B verifies the proof using its own secure knowledge of chain A. It doesn't trust the relayer telling it.
Exactly. The security comes from the cryptography and the light client verification, not from trusting the relayer. If a relayer tries to cheat, the proof won't verify. If a relayer just fails or goes offline.
What happens then? Are my funds stuck?
No, that's another critical difference from some bridges. If the packet isn't successfully relayed and acknowledged back on the source chain within a certain time, the transaction basically times out and the funds are automatically refunded to your wallet on the source chain. Your funds aren't locked in some vulnerable third-party contract.
That sounds significantly safer than many of the bridge hacks we've heard about.
It's a fundamentally different and generally more secure trust model compared to relying on, say, a multi-sig controlled by a few parties, or complex smart contracts on an intermediary chain which can have their own bugs or exploits.
Okay, that's impressive. And you mentioned IBC isn't just for sending tokens, right? It sounds much more general purpose.
Oh, absolutely. Far from it. The flexibility of IBC, the fact that it's about sending arbitrary data packets, opens up a huge range of possibilities. Token transfers are just the first, most obvious use case.
So what else can it do?
Well, you've got things like cross-chain swaps and forwarding. Imagine your chain doesn't have a good decentralized exchange, but another IBC-connected chain does. You could potentially send your tokens, have them swapped on the other chain's DX, and receive the new tokens back, all orchestrated via IBC.
Wow, okay.
Then there's interchain security. This is really cool. A well-established chain, the provider, can basically lend its economic security, its valuable set of validators and stage assets, to newer, smaller consumer chains. The consumer chain benefits from high security from day one.
So new chains don't have to bootstrap their entire security model alone.
Exactly. IBC also enables things like streaming Oracle data. Chains can request real-world data feeds, like price information for DeFi, from other chains over IBC. We're also seeing innovations like cross-chain liquid staking. Protocols like Stride use IBC, plus another feature called interchain accounts to let you liquid stake tokens from chain A on chain B, all managed from one place.
That sounds incredibly convenient for users.
It is. And maybe the most ambitious part is extending IBC beyond the Cosmos ecosystem. They're actively working on bridging to non-IBC chains, using what are called peg zones. These essentially figure out how to establish a kind of finality for chains like Bitcoin or Ethereum, which are probabilistic, making them compatible with IBC's requirements. IBC version 2 is specifically targeting connections to Ethereum and Solana right now.
Connecting to Ethereum and Solana via IBC. That would be massive. So taking a step back again, what's the really big picture impact of this whole architecture, Comet BFT, SDK, IBC? What does it mean for the future?
Well, I think if you connect all these dots, the fundamental belief behind Cosmos is that trying to force the entire global economy onto one single blockchain with one set of rules, it's just not realistic and maybe not even desirable.
Too much diversity in needs and governance.
Exactly. By enabling all these different sovereign blockchains, chains that can set their own rules, have their own governance to still communicate and interoperate securely via IBC, you foster this incredible environment for permissionless innovation and experimentation. It's about scaling socially and economically, not just technically.
Giving different communities the freedom to build their own digital nations, but still allowing trade and communication between them.
That's a great way to put it. It gives users and developers ultimate freedom to choose the rule sets they want to operate under, while still being part of a larger interconnected whole. Chains can evolve independently, but still interact.
That is a really powerful vision. It's definitely complex when you get into the details, but understanding these core parts, BFT for consensus, ABCI is the messenger, the SDK for building, and IBC for connecting it, really does feel like you're seeing the blueprint for a truly interconnected Web3.
Indeed. And just think about the kinds of applications that become possible now. Applications that can pull data from one specialized chain, use compute on another, and custody assets on a third, all seamlessly and securely. It opens up so much design space. So maybe the question to ponder is, what kind of multi-chain applications could you imagine building or using now that these chains can finally talk to each other properly?
That's definitely something to mull over. Thank you so much for walking us through that. It was a fantastic deep dive. And thank you all for joining us. Until next time, stay curious.